Greetings to all. We are going to see about the dynamics lab experiments, the experimental study of kinematics of slider crank mechanism. And the objectives of the dynamics laboratory is this lab refers to study the simulation system of motion based on the forces acting on it. And these experiments to enhance the knowledge of force analysis in the dynamic system and improving the understanding of concepts and basic concepts of kinematics of machines and dynamics of machines. And slider crank mechanism. The slider crank mechanism is one of the most basic forms of closed loop mechanism. It is a modification of basic 4-bar chain. It has the single degree of freedom and it is often used to convert the rotary motion into linear motion by varying the link lengths. It is usually found in reciprocating steam engines. The purpose is to convert the rotary motion into linear motion, the slider crank mechanism. It is a modification of basic 4-bar chain. And from an application perspective, it is important to understand the dynamics of such system. The kinematics of system is largely governed by the link length and so the dynamics of the system. Through the process of the simulation, one would understand how to calculate the forces on each link at constant angular velocity as input out. The dynamic analysis of the slider crank mechanism is covered after understanding the kinematic analysis, since the acceleration of links are required to calculate the forces on the link. And aim of the experiment is to study the kinematics of slider crank mechanism, also determine the plot of the velocity of acceleration of the piston. The first one is the angular velocity and acceleration of piston. Second one, crank angle with displacement of slider. Third one, crank angle with velocity of slider. And fourth one, crank angle with acceleration of slider. And apparatus required for the slider crank mechanism. A working model of the slider crank mechanism is required. And the formula for calculating the values of slider crank mechanism are crank radius, L length of connecting rod, theta angle made by the crank with IDC, and pi inclination of the connecting rod, x displacement of the slider, and Vp is equal to velocity of slider, Ap is equal to acceleration of slider, omega Pc is the angular velocity of connecting rod, and alpha Pc is angular acceleration of connecting rod, and N is equal to 1 by R, which is known as a obliquity ratio. And the formula for calculating the displacement of slider, x is equal to R into 1 minus cos theta plus sin square theta divided by 2n. And velocity and acceleration of the slider formulas are shown here. And the angular velocity and angular acceleration of the connecting rod, that is omega Pc and alpha Pc values. And angular velocity of connecting rod, since sin square theta is small compared to n square, it can be neglected, hence the equation becomes w cos theta divided by n. And angular acceleration of connecting rod, and the equation 2 becomes alpha Pc minus omega square sin theta n square minus 1 divided by n cube. Also unity is small compared to n square, it can be neglected, and so that alpha Pc is equal to omega square into sin theta divided by n. And the procedure for calculating the values of slider crank mechanism: bring the slider to IDC position and make the slider to rotate an angle of theta degree and measure the displacement of the slider by using the scale which is fitted into the slider crank mechanism, and vary the value of theta and measure the corresponding displacement of slider, and use theoretical formula to calculate the displacement of slider and calculate the required data by using the formulas. And finally plot the graph between crank angle with displacement, and next plot the graph of crank angle and velocity of the slider, and the next plot the graph between crank angle and acceleration of the slider. And this video you can understand very clearly about the slider crank mechanism. crank, slider and connecting rods. Procedure for taking the wheel.
Measure the length of both crank and connecting rods by using the ruler provided. Choose the desired connecting rod and place it to the crank holder and the slider holder. Make sure that the crank and slider system is moving correctly. Set the position of the crank to 0 degree by referring to the protractor on the apparatus. Then, record the initial position of the connecting rod at the slider's end by taking the value directly from the ruler on the apparatus. Next, slowly rotate the crank and record the position at the slider's end for every 30-degree increment. Take the reading up to 660-degree rotation.
And this is a procedure for the slider crank mechanism measuring the values for each 30 degree. And this is a graphical method for drawing the velocity diagram and acceleration diagram. And this is a tabulation for the slider crank mechanism, and the sample readings were calculated, and the table shows that the slider crank mechanism readings, and initially 0 degree, and after 30 degree, 60 degree, and 90 degree, 120 degree, 150 degree, 180 degree. The angle displacement is gradually 30 degree, and the time for rotation 0.05 seconds, and position and displacement and velocity and acceleration. And the position is 0.009, and the displacement is difference between the values, that is 0.004, and the velocity 0.18 meter per second, and the acceleration 3.6 meter per second square. And this is a model calculation for the each readings, displacement of slider and the velocity of the slider and acceleration of the slider. And after calculating all the values by using the model calculation, we can tabulate the values and calculating the values, and then finally draw the graph for crank angle with displacement of slider, and crank angle with velocity of slider, and crank angle with acceleration of the slider. And thank you for watching this video.